over, that means you have to stop. So you have 15 minutes for your presentation. Okay, before I do that, let me hand over the mic to the chairman of the room, who will take us coordinate the session, Dr. Business. Please let's welcome the chairman. Yeah, thank you so much. So, like it said, we'll be having 4 presentations today. So, 2 physical, while the remaining 2 will be virtual. So, we move on to have Mr. Program to come forward for his presentation. Each presentation will be given 15 minutes. So while question and answer will follow up immediately within the next 5 minutes. So join me to welcome Mr. Albert, his presentation.
Let's move forward on the once this starts, range is coming. So that I don't want to do my house. I got cutting to do. Okay. Hey, clap off. If I check the slide, not responded. The answer is just it's not. Okay. Wait. Please, can you ensure that Sagaba. Your mic, sir. You are not using your mic.
My name is Icammwa. I'm presenting the topic mathematical assessment of systematic areas in cerebral meningitis transmission, evidence from the Nigerian live setting. Cerebrospinal meningitis (CSM) is an acute infectious disease of the meningitis, mainly caused by Neisseria meningitis, with additional contributions from Streptococcus, pneumonia, and Haemophilus influenza. These groups, the OPC, W, X, Y, are responsible for epidemic outbreaks. Nigeria lies within the African meningitis belt and experiences recurrent epidemics despite vaccination and surveillance network, including a major outbreak in 1996 with over 109,000 cases. Transmission occurs mainly through close respiratory contact, especially in overcrowded settings. Carriers act as silent reservoirs, sustaining transmission during inter-epidemic periods and initiating future outbreaks. Despite reductions in cell group, following vaccination, emerging cell groups C and X continue to derive recent outbreaks. Empirical and theoretical evidences show that carriers substantially influence transmission dynamics and can maintain average even when symptomatic cases decline. Previous meningitis models incorporate seasonality, transient immunity, climate effects, and vaccination, reproducing observed epidemic patterns. Control studies show combined vaccination and non-pharmaceutical measures are more effective than single strategies, with optimal control identifying vaccination as cost-effective in Nigeria.
Okay, slides.
However, most studies focus on symptomatic infections and short-term dynamics, giving limited attention to asymptomatic carriers.
Yes.
Say, just help with that.
Next slide. Okay. Issue is between them.
This is a schematic diagram of the model and the model equation that follow from it. The first equation, cost of infection, and the second sort of equation is the model itself. These are the parameters description. The analytic results obtained. Well presentness, invariant region, basic reproduction number, which shows at the sum of two different listings, the symptomatic infection and the asymptomatic infection. Stability analysis is also carried out. This free equilibrium is locally and globally asymptotically stable when the reproductive number is less than 1, and it has a unique endemic equilibrium and is globally stable when R0 is greater than 1. Sensitivity analysis of the model is carried out. The parameters show those compounds are the ones that are positive and the are the ones that are negative. The heat map for the numerical analysis and the 3D visualization. We have carried out two important parameters that are responsible for the asymptomatic areas. One of them is the one we call ETA, and then the other one is kappa, the proportion of those responsible for asymptomatic. And those are the numerical solutions showing the first one, figure 3, showing simulations, showing the effects better on the dynamics of exposed population. And then this figure 4, showing the effects of beta on the dynamics of symptomatic infectious population. Figure 5 shows the effects of beta on the dynamics of asymptomatic areas population, and figure 6 shows the effects of beta on the dynamics of the covered population. Interpretation of the models. Well-positiveness. By well-positiveness, it guarantees that the model admits unique, positive, and bounded solutions, ensuring biologically realistic dynamics and validating all subsequent analytic results. The invariant region. We establish a positively invariant region showing that all solutions remain non-negative framework for equilibrium and stability analysis. The production number explicitly separates symptomatic and carrier-driven transmission, showing mathematically that asymptomatic carriers can independently sustain outbreaks even when clinical populations are reduced. Our stability analysis shows a sharp ratio when R0 is less than 1, the meningitis dies up. But when R0 is greater than 1, the disease persists endemically, driven in part by asymptomatic carriers. The sensitivity results show that asymptomatic carrier infectivity and transmission rate are dominant drivers of R0, meaning that controlling silent transmission is essential for reducing meningitis outbreaks. The heat map and 3D plots show that carrier infectivity and transmission interact strongly to drive R0 with steep surfaces indicating high sensitivity, confirming that asymptomatic carriers significantly amplify meningitis persistence. Figure 3 illustrates that increasing beta accelerates the accumulation of exposed individuals, producing higher and earlier peaks, which indicates that contact intensity strongly drives human transmission and outbreak magnitude. Figure 4 demonstrates that higher value of B produce earlier and larger infection peaks, demonstrating that transmission intensity strongly governs outbreak magnitude and healthcare burden. In figure 5, the overlapping curves indicate that carrier dynamics are relatively insensitive to transmission intensity, suggesting that clearance and progression rates, rather than contact rate alone, govern carriage resistance. Contextualization of results. The analytical and numerical results consistently demonstrate that asymptomatic carriers significantly elevate the basic reproduction number and sustain long-term transmission. This findings aligns with epidemiological evidence that meningococcal carriage persists between outbreaks and sales subsequent epidemic. In the Nigerian context, where surveillance primarily targets symptomatic cases, this result suggests that silent transmission remains largely unaddressed. Consequently, interventions focused solely on clinical treatment and vaccination may be insufficient for durable disease control, highlighting the need for carrier-connected strategies and improved community-level surveillance. Public health implications. Our findings demonstrate that asymptomatic carriers significantly sustain meningitis transmission, implying that effective public health control must extend beyond symptomatic case management to include carrier-focused surveillance, sustained vaccination, and transmission reduction strategies, particularly in high-risk settings. Recommendation. Based on our findings, we recommend integrating asymptomatic carrier surveillance into routine monitoring, strengthening transmission reduction measures, sustaining vaccination coverage, and adopting integrated control strategies. Addressing silent transmission alongside clinical case management is essential for achieving long-term meningitis control in Nigeria. This study employs a deterministic compartmental framework with homogeneous spacing, which may oversimplify real-world contact heterogeneity and localize transmission patterns. Age-specific susceptibility and carrier dynamics are not explicitly modeled, and parameters are primarily drawn from literature rather than fully calibrated to Nigerian time series data. In addition, seasonal climatic forcing known to influence meningitis outbreak is not incorporated, and carrier dynamics are represented in aggregate without accounting for serogroup variability. Despite these limitations, Model provides valuable qualitative insights into the role of asymptomatic carriers and establishes a theoretical foundation for more detailed future investigations. Future direction. Future work will focus on parameter estimation using Nigerian surveillance and current data to calibrate the model and improve its quantitative predictive capability. This will enable more accurate assessment of outbreak, timing, and magnitude. In addition, the model will be extended to incorporate signal forcing to capture patterns. Finally, optimal control frameworks will be developed to evaluate the cost effectiveness of integrated intervention strategies, including vaccination, treatments, carrier screening, and transmission reduction measures. Conclusion. The deterministic STICR model was developed to assess the impact of asymptomatic carriers on cerebrospinal meningitis transmission in Nigerian large setting. The production model was shown to comprise both symptomatic and carrier-driven components, revealing dual transmission pathways. Stability analysis demonstrated a threshold behavior. The disease-free equilibrium is globally stable when R0 is less than 1, while a unique endemic equilibrium persists when R0 is greater than 1. Sensitivity analysis identified transmission rate and carrier infectivities as key drivers of outbreak dynamics, and numerical simulations confirm that asymptomatic carriers act as silent reservoirs sustaining transmission. These findings indicate that controlling symptomatic cases alone is insufficient for long-term disease elimination. Effective control requires integrated strategies combining vaccination, transmission reduction measures, early treatment, and carrier-focused surveillance. Future work will incorporate parameter stabilization using Nigerian data and extending the model to include seasonal and demographic effects. That's the thing. Thank you very much.
Okay, thank you so much for your presentation. You have added your time. Okay, we appreciate that. So it's time for question and answer. Mr. Oga has presented. But let's take it back so that we engage in all of this stuff. Okay, please raise our hands once and for all so that I can give number one. Question? Okay, bro. Okay, let me give you. Thank you very much for this nice presentation. This is cannot seen. This is not a query, but a relation. You have shown that the system can be disease-free not less than 1, and it becomes a negative not greater than 1. And in the simulations, you have done all the numerical computation with respect to most probably it is beta. It is beta. So how the mathematical results relate with the simulation results? Because your mathematical results based on R naught, whether it is greater than 1 or less than 1, but you have not used R naught in the simulation directly, and then you have considered a different parameter. So my suggestion is that you should consider R naught also in the simulations, and then you can add any other parameters just like beta. Thank you.
All right, thank you so much for your presentation, an observation, and then 2 questions. Okay, I was trying to get your attention while you were presenting why so that you decided to face the board. You didn't talk to us, so maybe it would be good that you give us that eye contact to that. we can see what you are talking about. Then, I would want you to go to your model and give us a detailed explanation of the model, how things flow, particularly from the flow diagram as it leads to the equation. I'm not sure if the same following. Then the second thing has to do with this is simulation results, particularly the heat map. I would love to you to explain the heat map to understand what you are trying to assess, what does the heat map mean in interpretation. I would appreciate that. Thank you.
Parameters responsible for the asymptomatic carriers, one the proportion kappa, one minus kappa, and then the other one eta, the infectivity parameter. I use here, and from look, check the vertically there is the infectivity, and then okay. All right, and then 1 minus kappa, that is the progression to over the asymptomatic. So when that is high, and the infectivity is low, you can see the value there, and then it is dangerous when the infectivity and the asymptomatic carriageway are both high. Look at them. So you can see the map there. You have this value here, the first one blue, and then this red here, and then this other red. So it shows that at this point here, this one here is high, and this is high, that is dangerous. But for instance, like when the infectivity is low, and then the portion is low, you can find the value there, then at that point, there will be no project like this will happen. Don't know if I've answered the
So that's one of it.
model.
Equation. So diagram. Good person.
Right? We have divided population into 5 non-setting susceptible, exposed, infectious, asymptomatic carriers, and then the recovered population. 5 years stands for the recruitment rate. Lambda is the force of infection, and it's defined, it's shown there. This is eta there, which is the infectivity parameter. N is the total population when we add S, T, I, C, and R. Beta is the transmission rate, and then we have S as defined, and then E defined as follows: I, C, and R. I think something I've missed out something. The initial values is not put here. I've discovered that that's not intentional. I apologize. The initial values I omitted them.
So I think it should be partially satisfied with your explanation. So I will just take it further a bit. So your recommendation was emphasizing on vaccination. Initially, I was thinking that your model captured vaccination. So what led to that recommendation based on the findings of this study? Because you talk about the increasing the coverage of vaccination as if there was a baseline coverage that you already originally captured in your work. I could not see that in your model. So what led to increasing the coverage?
See, you will find that upper and the eta has a way of affecting the second part of the reproductive number. So when yeah, so the R naught is then you take it that even if you reduce the effective symptomatic disease, you still have this in the population. So that means that, well, even though we have not a new translation, that means that you will do translation and such that is when even though you have reduced the number of those who are carriers of infections at that time, this population will still causing harm in the community.
So I may say that I understand your arguments, but my concern is that when you presented it, it's as if vaccination is originally captured in your work. But you can link that up to maybe a beta, which is the transmission rate now. We know that if we intensify an effort that will reduce that beta, it will lead to decreasing transmission rate, isn't it? And one of the things one can do is to introduce vaccination. You just make it like a proposal that based on what you observe on this, an intervention such as vaccination can be looked into. Not that the recommendation will come directly as if you originally captured it, because you mentioned about increasing, whereas there is no baseline of it. So thank you. So on this note, we appreciate your presentation. So thank you so much. So we will proceed on to next. So we move on to all of the second presenter. Are you ready for us?
Since you said time. Can you switch this? Can you continue in that? She shared. Are you said? Sure. Yeah, sure. That's this one. This one is. What?
It says going on.
It's still the down again. It's the channel. Check out your batteries. What I'm saying is, we're using just one. I don't know how the second joke, so that the chairman will have reality. Only going up and down. Yeah, only my turn. Yeah, but I don't know what is God from chairman. It's really not being up and down.
This need the persons last slides.
It's all work, yes. All work.
We are still.
It's interesting. Just about this. So if it's important. It's just happening. What we do. That's fun. Okay, me if I don't ask question, it's working out.
What am I getting?
We can.
Amazing is Firefly.
There's no reason.
I'm doing something. I decided to check my exam. If we are taking us there. I don't understand maths. I don't be taking mathematical modeling. It's a 5.7.
Okay, so we have is a issue from this to impact of online learning platforms on university on graduate based on achievements in computer science education courses. And state. So we have just here from the Thank you.
Thank you, sir. Thank you, my pros. Thank you, everyone. This is part of my thesis. Portion of it that has been published. We were looking at impact of online learning platforms on university undergraduate student achievement in computer science education courses in universities in Anambra State. So we considered all the public and the private universities. So, in the 21st century, technology has radically transformed the educational landscape, offering new and dynamic ways for students to engage with learning material. Online learning platforms such as Zoom, Coursera, and Google Classroom has become integral to online education. This platform provides flexibility and accessibility, enabling students to learn from anywhere and at any time. The increasing shift from traditional face-to-face instruction to online education, especially in the wake of COVID-19 pandemic, has raised questions about the impact of these platforms on students' academic achievement. So within the time of COVID-19, we discovered from our universities in Anambra State that we moved from traditional face-to-face learning to online learning so that students will not suffer in their education. But even as that, we have not been able to capture what exactly the impact of this online compared to traditional face-to-face learning. So that's what this research is all about. The adoption of e-learning platform has been a revolutionary approach in the tertiary education, especially in technology fields like computer science education. So in Nigeria, in Anambra State and other higher institutions around us, we're embracing online learning platforms already to enhance education services and students' performance. Yet the adoption of these online learning platforms also varies extensively by types of education institutions, leading to complex scenarios of technology adoption and academic performance. That's why we're looking at public and private, looking at how what differs between the public and private in adoption of this e-learning and the usage of it, and even amidst the public and private, how do female and male students perceive it? Because we discovered that during the study, so our aim is to investigate how internet learning platforms influence the academic achievement of undergraduate students in computer science in different kinds of universities in Anambra State. Through the investigation of the difference between public and private universities, the study aims to acquire in-depth understanding of the potential of digital learning platforms in enhancing academic achievement in a changing technological learning environment. Beyond academic curiosity, the significance of this study extends beyond academic interest. Understanding the impact of online learning platform has the potential to inform institutional policy, inform investment in technology, and ultimately lead to enhancing the delivery of computer science education efficiency as it ought to be. So the gap we're looking at is that despite the potentials in online learning platform, there is little or no information from the literature on how this platform stimulates the students' interest and also affects their success in learning. And when we talk about success in this aspect, we talk of their achievements. There is also little or no information on how public and private institutions in Anambra State assess student performance with regards to these platforms. Students are just using it, but when they're going to be tested, they will still be tested with traditional face-to-face methods. So we want to know if we are adopting all this online learning for our students, when they are being assessed, they should be assessed with e-learning also, so that we know whether there is an impact on the student. It is discovered that implementing them has several challenges also. Yes, we have several challenges because some students till now may not be able to access mobile devices. Some of them, recently in Nigeria, we have hike in data prices. Before you can get 1 gig at 15 naira or thereabout, but now you can even, in fact, even if you spend 5,000 naira on data before you know what is going on, there is no more there. So these are part of the challenges. And unstable electricity. Many of us they are using solar system, and it's not everybody that can affect it. So some schools actually cannot affect this solar system for the students so that they will be able to check how they are using it and the impacts on them. So here we are looking at specifically the student impacts of this platform on student achievement, both in public and private, and both on female and male undergraduates. So we believe that this study will benefit our students, lecturers, curriculum planners. The study was carried out in Anambra State, and we used 200 to 400 university undergraduate of computer science courses to do as our population. We omitted the 100 level because they are not used to both the conventional and the online learning. So they can give us a meaningful information on what we are doing. So these were the things we reviewed. So the question guiding us is, what actually is the impact of this platform on public and private university undergraduate students in computer science in Anambra State, and how does the impact of these online studies differ between male and female in the same universities? Then we're looking at the hypothesis. There is no significant difference in the perceived impact of online learning platforms on undergraduate students. Then we are looking at there is no significant difference also between how male and female students perceive it. So the method we use is descriptive survey. We use it because we needed to interact directly with students. We did not go to employ data from anywhere. No, we use survey design, in that we designed our questionnaire, go to the schools. We use 3 schools, Nnamdi University, Chukwuemeka Odumegwu University, and Madonna University. So we go to the students, interacted with them. What is your view about this module, Coursera platforms? What can you say about it? How do you use it? And all the information they gave us, which was our primary data, was what led to our platform. So the instrument for data collection, it was validated by 3 experts, and we checked the reliability with Chrombat Alpha, and we got reliability coefficient of 0.81. That gave us the assurance that the instrument was good for what we are doing. And the data we obtained, we used weighted mean, standard deviation, and t-test to analyze it. Then our hypothesis was tested at 0.5 alpha level using t-test. In our decision, criterion mean was used as item with mean 2.5 above was considered as agreement, while any item below 2.5 will be considered as agreement. Also, we checked that if P level is less than or equal to significance level of 0.05, then the null hypothesis was rejected. The null hypothesis was upheld if P value is greater than or significant level of 0.05. And from the findings, we say generally, from the findings, we discovered that students, all the students in private and public universities in Anambra State, they agree that online learning platforms offer a wide range of courses that supplement traditional instruction in computer science, because we are not looking at scraping traditional method of teaching. We are looking at making online learning as a supplement, and from the data we got, they agreed to it. We also saw that students of this school, both male and female, agree that the use of online learning platforms has positively influenced their overall academic performance in computer science. And also, the aspect of it that we call gamified learning has increased their engagement, potentially leading to better academic achievement. Because before now, when we were considering it, we are like, will male and female students perceive it alike? Who can engage in online learning platform? Is it the male or the female? But when we checked it, we discovered that there was not actually different. Then from our null hypothesis, we discovered that there is no significant difference in the impact of online learning platform on university undergraduate student interest in computer science courses between public and private university. We were thinking that public university will engage it more. But when after we analyzed our data, we discovered that both the private and the public university are saying the same thing, that they need to adopt an online learning platform. And there is also no significant difference on male and female students, which means that both male and female students agree that engaging in online learning platforms can increase their academic achievement. It can be concluded based on the finding that online platforms have a positive impact on student academic achievement in computer science. The positive impact arises from availability and diversity of courses on online platforms, the provision of accessibility and updated content, and the adaptability of online platform to individual learning. So from here, we draw our conclusion that unlike traditional learning, online learning platform actually offer a wide range of courses, and they have a way of engaging students. In fact, some of them, after some 10 or 15 minutes, they decide to give you a quiz or a game just to boost your interest, and it will continue. And when you don't understand one or two words or any content, it can direct you to get it immediately, unlike traditional face-to-face learning. Thank you.
Thank you for your presentation. So, please, it is time for questions and answer. I have questions, and I was expecting that. Okay. Number one, number two, then number three. Yes. Thanks so much for the presentation. Such a wonderful work. So actually, I have two questions. One is, first is more like a concern, because when we talk about general educational field, most of the things that we actually think should be a normal like conclusion, like, oh, if students learn with online platform, they will most likely perform better than students that were taught traditionally. Or when we get these things by survey, so sometimes it can actually be misdirecting. So I just suggest that probably you can also consider making use of like a past experimental study instead of just doing a survey, because sometimes the way to actually make these things have significant difference is you have a control group and you have a treatment group. So people are sort of using online-based learning, while some people just go with traditional, and you cannot compare their score, maybe using cover all of this stuff. So actually get whether there's actually significant effect. So the second question is, please can you go to the findings under the, I think the fifth one. So there's a particular place where you talk about interest. There is a significant difference in interest of male and female. Yes. No, the fourth one, yes. Although when you are talking about it, you actually said there is no significant difference. But on the slide, to say that there is a significant difference in the impact of online learning platform on male and female university undergraduate student interest in computer science education courses in Anambra State. So my question would be, so if there's a significant difference, who has more interest? Is it the male students that have more, that are reported to have more interest? And I intentionally use the word reported because some of these things, if you don't actually like measure the effects, because even the title of the research also said impact. And I don't know, maybe it's my thing, but I felt like most of the time to actually measure impacts, you have to go deeper than survey. So I just want to ask, which of these actually have more interest? Is it the female or more? Is it the male that have more interest based on online learning platform? Thank you.
All right, thank you so much for the observation. Actually, why we omitted the 100 level student was because of that. We using quasi-experimental. But we discovered that in doing that, we may not be able to get it within the time frame of the study. That is number one. Because the students all the while have been using traditional face-to-face, which is our control group. But we introduced online platforms from 200 level for some time. So these students that we use now have already tested conventional and both online. So that's why I said that we use 200 to 400 people that we are sure have tested the two and can be able to give us a feedback. Then I merged the answer to the research questions and the hypothesis. So in reporting to the research questions, both the female and male students agreed that online learning platform has a way of boosting their academic achievement, boosting their retentions, and exciting them to learn from online traditional face-to-face. But a significant difference actually, we discovered that the value they got were not the same. But it was also a surprise that the value for the female was higher than that of male. That female agreed that using online platforms is more engaging for them than male.
What is that? Where listens what she said. What did she say?
She said females are three that of online, but
Then
Thank you.
female.
Female.
Hey.
If I got you right, you said you use survey and that you interacted with students. Form of interview. Do you answer the question here? Okay, well, you said one-on-one in your listening. I would have said your work is turned toward the qualitative, not qualitative. If it's something you know, and you also say one-on-one, then your work is not qualitative. Then it's okay. Number two question. You said 2.5 is your baseline. 2.5. Yes, anyone that is from 2.5 and above, you accept the hypothesis. Less than that. How to ask you? You use 4 scale, like or 5 scale. Which one do you use? 4. Okay. That's okay. Then right. The last question. Please go to last one of your conclusion. This is your findings. There's one. No conclusion now. Findings. Let's say about this. Number 3. All right. There is no similar difference in the impact of online learning platform. What do you make of this? What's the meaning of this? This one is saying that whether you learn online or traditional, there is no what significant difference. That's what it's saying. You know, it's going to say if the online, that I just now alone, I've put that where I learn online or traditional, that's no different. That's the meaning of what I'm saying. So please go from it. There's just that in the impact. Let me like this. In the impact of online learning platform, basic graduates, student interest in computer science education between public and looking on the great impact there. So it's okay, but you know to look on that area. Yeah, I'm looking at the impact. Not looking at the interest. So you have to inform me to also come to what one. Thank you.
Okay, maybe to help you present better, we'll give the client.
After what?
No question, I just wanted to.
Thank you very much for this opportunity. On this finding, what I understand with this statement, she is trying to compare the impact of online learning of students in public university and that of private university. And she said there is no difference, no significant difference. In relation to her work, she said she wants to know the impact of online learning for students in computer science. First sample, public university. Second sample, private university. She's not comparing online learning with traditional or the enhanced learning. So this statement is very correct. Thank you.
Thank you very much, Mr. Blessing, for your presentation. See, part of what you have solved this problem would have been if you have us. What did you say you use? Is it T-score or what? Analyze. You didn't show any table, you didn't show us any calculation you did. If we have shown such, we should be able to conclude where your calculated and the value on the table value, the calculated value. You should have explained it better than it is. Then, let's go to your topic and your research question and hypothesis. You know, your topic is supposed to have dependent variable and independent variables. What I mean is what you are testing really and what are the other variables and the rules to arrive at, like you are looking at private and public. You are looking at male, female. You can change those ones to arrive at what you want, independent variable, to look at the independent variable. Now, your work, is it basically for computer science students? Students studying computer science in university. Okay. Or students, education students in a university. Please answer that so that I can do what's important. Are you looking at students that are studying computer science or students that are studying education? Computer science. Okay. Because my question wanted to be, I should have asked, do you prove the impact of non-computer science-based courses? So, for example, somebody studying public admin or religious studies may not really find it very easy using computer-based learning system. But since it says that it just covers only students that are in studying computer science. Now, what did you use to test for your decision? What? Okay. Because I'm looking at the fact that you mentioned two tests. Somebody who is a layman here in that area, you didn't even give us anything related to tests. There's no table of values, the average, small, the data you collected, and you in taking decision, natural meaning was used. I was thinking in a research like this, you have used test retest method. You know what I mean by test retest? You gave them maybe a test based on the CBT. They answer that one. You can rearrange the questions. Question 1 can become question 30, 30 become question 2. Rearrange them, mix them up, test again. Sometimes we try that test and retest method so that if the result is stable, because you have not really told us why you agree to use that question. Now, you know, you're supposed to test the validity of that question here before you administer it. Okay, set by H5. Okay. Okay. Thank you.
So thank you so much, everyone, for your contribution to this talk. I think at this point we end this session. So thank you so much for the presentation. So we have to. All right, thank you so much, Chairman, for that session. And we are done with that session, which I think was a beautiful one. For the sake of our online participants, we are going to have the next keynote speaker come up now before to get ready for lunch. So after the keynote speaker, we will go for lunch. Then when we return on lunch, we have the last two presenters that are online. They are online presenters. And you know, is it not beautiful? If you look at it now, the theme is mathematical and theoretical biology. And you will expect papers to be presented within that context, as was presented by Mr. So when we saw, you know, we have to garnish it with something from education, assessment, and all of that. It's good, it's beautiful. Anyway, we had a presentation, we had a conference last. Okay, we had a presentation, a conference last 2 weeks ago, and then she could not make our presentation, and we felt that's no problem. We can garnish even biology with education. After all, biology without education, what do we call that? So it was a beautiful one that we saw that kind of presentation too. Now we will be going for the next keynote speech, and that will be delivered by Professor Sucking Dabs, who will be doing that presentation. But before we do that, we are going to read the citation of Prof, and that will be done by one of our scholars, Mr. Oluwaseun Ogbodere. So please join me to welcome Mr. Seun. And then Prof, please, we have your attention. Please come over. Thank you. So the citation of Professor Kendas Christos. Professor Kendas is a distinguished Indian physicist, an academic leader currently serving as a senior professor in the Department of Physics at Jaipur University, Kolkata. Born on July 29, 1964, he has dedicated over 3 decades to the advancement of material science and nanotechnology. His academic journey is deeply rooted in Jaipur University, where he earned his MSc in 1990, followed by a PhD in 1995, and later an MBA in 2001. This multidisciplinary background has allowed him to approach scientific innovation, focus on both technical excellence and practical application. Throughout his professional career, Professor Kendas has become a prominent figure in the global scientific community, particularly in the fields of nanoscience and nanophysics. He leads the biophysics laboratory at Jaipur University, where he oversees cutting-edge research into energy harvesting and environmental remediation.
His work is primarily centered on the development of piezoelectric nanogenerators, multifunctional fluorescent nanosensors, and advanced supercapacitors. Beyond his research, he plays a vital role in institutional governance as a member of the doctoral committee and the physics research committee, helping to shape the academic trajectory of the university's faculty of science. The impact of Professor Khan's work is reflected in his prolific publication record and high citation metrics. With over 270 scientific papers to his name, his research has earned more than 9,000 citations, resulting in a high age index that places him among the leading researchers in his field, according to the study. His scientific contributions have earned him a place on the prestigious Stanford University list of the top 2% of scientists in the world. Today, he remains a key figure in developing sustainable energy solutions and innovative sensors, bridging the gap between theoretical physics and real-world environmental and biological applications. Join me as I welcome Professor Glass as the next speaker of teaching. Thank you, sir.
For giving me a chance to deliver about my research work. I will tell something about my research work. It is not about anything related to the model, but modeling is there. One thing is there related to the development of our improvement of our okay. So today I will just give some idea about my research work. I am from Jalpur University, which is one of the best universities in India, and at least more than 45 number of teachers are there who belongs to the top 2% of the Stanford list. Top 2% best scientists of the Stanford list. So I am proud to be a part of that university. So I just started my work. Today, so this is the whole work of my lab. Someday I have seen some patchwork in the hands and legs of one of my students, and this type of patchwork was there. So I asked my student to go there why this patchwork is there. So we inquire after that, and the student tell me that he is from a Bantala, he is from the area of Bantala, that is the Bantala is the leather complex of Calcutta. So my student went there and they found that the area is filled up with various waste material of that leather complex. And not only that, there is a canal, and this canal is, the water of this canal is completely dark. So they called me, sir, we are observing this, what can I do? Then I called them to collect some sand of that area and the water of the canal. They collected that. These are the student, a picture of my student. They collected that. And after chemical analysis, we find that a huge amount of chromium is there. Chromium is a heavy metal,
and the huge percentage of chromium is there. It is more than 2.58 ppm. And this chromium is responsible for that patchwork. And then our work is to identify this chromium in the presence of this heavy metal in the water, as well as how we can remove them from the water. This becomes a challenge to us. So we start our work from there. Actually, when chromium is more there, then this chromium we have seen that with the rainwater they are leaching inside the soil, as well as in the fruit, in the tree which is growing there, they are also rich with this heavy amount of chromium. So not only the water, the soil and air, all are contaminated with this heavy metal chromium, and this is causing a huge problem in that area. And this chromium is responsible for this type of disease. It may cause cancer, it may cause lung cancer especially. So what can we do? How we can do the identify this chromium and how we can remove that chromium from there? So this can be absorbed or ingested through our mouth and skin. And not only that, we have seen that your country is also huge contamination of this chromium. And in our country, especially few states are there who are much affected by this chromium. So we started to study the literature, and from the study we find that boehmite is a clay material which have some fluorescence property, and fluorescence property can be utilized to identify the chromium. So what we did, students after a long study, they identified that the chromium boehmite can be used, and not only the boehmite, with the boehmite, there are some gum which is called the acacia gum, which is available from the acacia tree. This can be used to identify the presence of chromium. How we can do that? Actually, from the picture we have seen, this is the picture of the boehmite, and we analyze that boehmite, whether it is pure or not, with the help of X-ray crystallography, and what type of bonding are there. We have done that with the help of fluorescence spectrophotometer, and from here you can see that the boehmite is decorated with the acacia gum. There is the dot of the acacia gum and the broad part of the boehmite material. And after analysis that, and after that analysis, we have seen that we published the report which we have analysis that we published that in these two papers. And after that, we find that if we make it UV spectrophotometer, then there is the absorption speed at 430, near about 430. If we increase the percentage of gum acacia in the boehmite, actually boehmite has the absorption at 430 nanometer. And if it is the grouping of the boehmite with the gum acacia, then the absorption increases. And after the increases, then it will be very much easier to identify the fluorescence property of the boehmite. But in that material, if we add the chromium rich water, then the absorption decreases. Now it is easy clear. We have prepared gum acacia boehmite material that have the absorption at 430 nanometer. Then in that water, if we add chromium rich water, then we find that the absorption disappears. That means this happens. Initially, it has a very good It is not mine. That is actually, we have prepared a Gamma Boehmite and make a solution of that. And that has a very good absorption speed at 30 nanometer. Then if we add chromium rich water, then that absorption will disappear and we will not get that absorption. And from there we can easily identify that the material, if the fluorescence property disappear, then we can easily identify that this material contain chromium mass in a mass amount.
Let's share this one down. Close this one out. So when you want that time, you closed. So always close the one of the team which I think we'll just.
Yes, yes.
Oh, yeah.
Yes. No, yes, that's good. It's been moved. So, no, this way. Nothing is that.
Actually, in the if we expose it with the light of 370 degree 370 nanometer, then we'll get a reddish fluorescence property of like this. Fluorescence property like this. But if we add chromium or chromium content water, then this light will disappear. So if we can find out such a device where this type of fluorescence property will be there, if we make 1 drop of water which contain chromium, then we can easily identify that the chromium is there or not. So in this way, 0.00025 ppm order also can be identified. It is very sensitive. We can easily identify this order of chromium also. And whether this material is absorbing only chromium or other heavy material, that is why we tested this with other heavy material, but we have seen that this material is only absorbing the chromium and reducing its fluorescence property. This is the thing. Other heavy metal, zinc, iron, chromium, cobalt, nickel, all we have used, but we have seen only chromium it is absorbed. So what is happening there? Actually, when we are 370 nanometer light is falling on this ground state, then some excited electron will go in the upper state and return back, and that is why there will be a fluorescence property. But if chromium we add there, then chromium will contribute with the electron, and that electron will not able to return back. That is why its fluorescence property will go away, and chromium will be absorbed in that boehmite material, and when it will absorb in the boehmite material, it will be there, and if we can remove that boehmite material from the water, then it will chromium will also remove with the boehmite material. This is the initial work of our lab, and after that we have also run this with the cell line W by 38 with the cell line, and from there we have seen that this boehmite material or ground acoustic content boehmite material is not harmful for our body, because from the cell line we have observed this also. So biocompatibility test is very important, because we are using to refine the water, and if this water is contaminated again, then it will be difficult. That is why we tested the with cell line. This type of fluorescence property we find when in presence of that boehmite, we will get a fluorescence property like this. So these are the all tests we have done. Now our interest is how we can make a device with the help of which poor people of that area can easily identify the material, as well as not only identify the material, we can improve the quality of the absorbing property and all these things. Then we start to study a modeling study with the help of the but to improve the quality of the material. How we can do that? Actually, boehmite is available in the form of crystal, well crystalline form. And we know if we reduce the size of the crystal, that means if we can make the nanoform of the crystal, then the surface of this nanomaterial will change. And this is the actual structure of the boehmite. This is the actual structure of the crystallographic structure of the boehmite. And this is the X-ray diffraction pattern of the boehmite. If these peaks are there, then you can easily tell that the material is nothing but the boehmite. And the intensity and the position, 2 theta angle is position. This is very important for the property of the material. Now, what happens if you can make the nanoparticle of the material? Then the surface area of the material will increase, and when the surface area will increase, then we can tell that the surface material will be responsible for the absorbing of the material. The surface will all absorb very easily from the material. So we start to develop various nanoparticles of the material. Here we can see from the hydrothermal process we have developed some boehmite material. It is after 12 hours, it is 18 hours, and this 24 hours. And we have seen that the particle size is very small, 3.2 nanometer and 4.1 nanometer and 4.8 nanometer we can get. And from the X-ray diffraction pattern also we verify that this is the X-ray diffraction pattern. It is for the 12 is black one, and for the 24 is the blue one. Because as the time increases, the crystal size increases. So as the crystal size increases, the surface area of the material is decreased. And at the same time, we also measure the fluorescence spectrophotometer so that any other bond will make their or not. And we verify that also under the electron microscope, and we have seen that the crystal size which we have verified under electron microscope is similar to the calculated crystal size of the material. Then we find out various optical property and electrical property of that material. But our main objective is to find out the crystallographic structure of the material, because whenever any crystallographic structure shifted little bit, then the charge particle, basically any atom is made up of some negative charge or positive charge or some neutral material. And neutral material also change some electric and positive charge. So negative and positive charge are very important. And negative charge and positive charge are very important. We get the fluorescence property due to this charge variation. When electron shifted from the ground state to the upper state, ground state to the upper state and return back, then we get the fluorescence property. So this electron the fluorescence property will go away when the electron will be bound by chromium in the upper state. So concentration of the charged particle in upper or lower state or ground state or upper state is very important. So we have to find out the concentration of the charge in various states of the atom. And if you want to find out that, then the most important thing is to find out the how the charge is distributed, and if we can find out that how the charge is distributed, then it is very easy. It will be very easy to solve the problem. Then we start to find out the X-ray structure of the material. This is the electron microscope which we have done. And finally, we start to do that in the model study. Well, as I told you, in this crystal, there in the surface, there are much charge particles are there. Whenever in the charge particle will be there, they will absorb easily or they will be able to influence the other. If you look into this structure, then you will find that this charge particle, and according to our quantum theory, each charge particle will act as a wave-like material. So this wave-like property will accumulate in some places and will be absent in other places. So we have to find out the charge density at various positions. If we can model that charge density of that material, then you can easily find out how that process property can be reduced or increased. So that is why we started to study two models. One is crystallographic model and another is DFT, that means density function study. And these two modeling study help us to find out the actual property of the material. There are the various type of crystal available. And if you look into this material, this is nothing but the quartz or silica. If we place this upper part will be rich with negative charge and lower part will be rich with the positive charge. As a whole, it is not like that. But when we will place that, when the crystal material, quartz material will be under stress, then the property will be like this. So in this property, you can easily find out that the upper part will be influenced by the negative and negative. Lower part will be influenced by the positive. So that means the charge distribution will be disturbed from the normal position. So depending on the pressure and all these things. So this charge distribution changes very much for the nanoparticle because surface area increases. The crystal which is inside the material is completely bound by the other crystal that don't have any influence of the surface charge. But that surface, if the crystal atom is on the surface, then it is covered in one side, but in another side, the charge can easily move. So the property of the material changes. As we know that depending on the crystal size of the material, gold can be red, yellow, or green, any color. So we measure this and we run this under the deep field condition. What we have done there, we have taken the structure of the crystal structure which we got from the X-ray diffraction pattern. From there we identify the phase and then run the regional measurement, and ultimately we got the final structure of the crystal. But we have measured there. Initially, we got this structure from the X-ray diffraction pattern. From there, we made various types of correction, that is peak profile correction, peak width correction, then the background refinement, scale refinement, and all this refinement we have done. And when we refine this structure, ultimately we will get the actual structure of the material, and that structure will be compared with the structure which we will get, and from there we will get a crystal structure like this, from where we can easily find out what is the density of the charge particle in the material. So this is the final picture which you get from the after refinement of the crystal. And from there, we will start to find out the DFT computation forward. That means the density function. Then what we do, we will the defined crystal get that the Vesta crystal that will get. Then we'll find out the super spread. supercell, and from there we will use some pseudo-potential. And that pseudo-potential will make a plane wave energy out of section and then keep. What is happening there? Actually, this is the supercell. If you look into this, if this is dope, this is a dope material. That means initially we dope Icammwa. Now we are thinking to dope some other material that may be transition material. So if dope this type of material here, then the structure of the material, the property of the supercell will change completely. So we have to find out what type of material we have got here, and depending on that, how the other heavy metal, then the property of the supercell will be different. And then, as we know that all charge particle can be used as a Feynman, from the Feynman refinement, you can find that all charge particles act as a wave-like material. So when wave-like material will be there will be a due to potential, there will be a potential and kinetic energy for each charge. If we apply a single potential there theoretically, then if we apply a potential there, then this potential will react with the potential of the charge particle, and from there we can easily find out what is the surface charge of the material or the density of the charge of the material. And we will get some picture like this. Here, what is happening? The potential due to the presence of the charge particle will be there, and we are applying a potential there. These two interact with each other, and from that interaction, we will get some interactive line like this. And this line, from this line, we can easily find out the band gap of the material, and this band gap is directly related to the presence property of the material, because as when the electron will go from lower state to upper state, and it will return back from upper state to lower state, it will emit the energy which it will absorb. And this energy, depending on this amount of energy which is absorbed, which is absorbed or released, the presence color will be different. So from here we can find out the band gap. This two difference is the difference of the band gap. So after doing this type of DFT learning, the modeling test or expectational test, we find out the ultimately density function. That means this is the density function, where the density of the charge will be more and where the density of the charge will be less. So after doing this, this is the how this is actually any atom can be represented by this type of equation. This part is the kinetic function, and this part is the potential function, and this is the wave from any charge particle contained in the charge form, and all these things can be represented in the form of the energy. So any atom can be represented in the form of energy, because E equal to mh nu and m equal to mc square. So we know that mass can be transformed into energy. So any atom can be represented in the form of energy. And when we are finding out the percentage of the energy in actually this is the thing where the density state, where the energy will be more and less. That is directly proportional to the mass of the material. So if you can find out this from there, this is the equation. This is the equation, this is the kinetic energy, and this is the kinetic interaction between the electron and the nearby nucleus, and this is the interaction between the nucleus, electron, and we have to calculate all these things. we can actually we find out the Hamiltonian of each electron, and if all electrons are sum up, you can have this, then we will get the actual impedance at atom. This huge number of plant will be there. Carbon that were called carbon molecule. There are oxygen. There are oxygen, carbon, and oxygen. So 66 carbon will be there. Similarly, if for a large molecule, there will be few thousand number of atoms will be there. And if we sum them, then we will get the density of the material only. So this is nothing but the density of, if you find out, then you will find the density of this material. And this is the density of the side stand is the density of the material. This 2 is only for the spin up and spin down. So what is happening? We are applying a pseudo potential, and that's the functional part of the charge particle. And from the charge particle, we will find the density of the material. Similarly, if we reduce the pseudo potential, then this density will return back to the functional part, and it will return back to the pseudo potential. And this may not be similar. It may be similar, may not be similar, depending on the atomic structure of the material. If it is not similar, then a constant part will be there. So we have to consider all these things. And from there, we find a graph like this. And from there, we can easily find out the band gap and the atomic structure and the density function, density state of the material. If the structure is like this, then the density function will be like this. If the atom is placed here, the density will change, and if another atom is placed there, then the density will change in different way. So now, depending on the doping material or undoped material, the density of the energy will change very much, and depending on the density of the energy, the fluorescence property will change because the energy absorption will change. So these are the similar thing for other materials where the band gap is less than the earlier one. So from this graph, we can easily find out the density. We have published work in a paper. And actually, I am just showing you the paper because if you want to find out the work, then you can search this paper and you will get this. So in this way, density is changing in the material, and I am just going to the similarly, one thing will be there. If it is a conducting material don't have any lower state or upper state. There are 3 electrons. Then if we measure the density function, then it will be like this. There will be actually conduction band and halide band will be each other. There will be no band gap there. So depending on the material, conducting material or insulating material, the density function will be different, and can be easily find out from there. Actually, we all do this thing just to know how we can, what type of material we can do, which material will give us the proper actual result for us. We have done all these things, and after that, I'm skipping this. You have gone in the earlier stage. With the bohemite, we drove 2. One is gallium GD and another is copper. These 2 we doped because these 2 materials give us the similar density function, which is similar to the doping of the diamond atmosphere in the bohemite. So we use these 2 type of material. One is GD and another is copper U, and we find out the crystal structure from there. And we know the this is when we add GD, then if you apply at the dope then the crystal are changing. So we measure all these things, and during this, we measure the process property of the material. There is any other bonding or there, the process property is there. From there, we find out the actual thing we have seen, the similar result what we have seen when we use gum acacia, but the absorbance is more. When we apply the chromium, then the absorbance is reducing, and in absence of chromium, the absorbance is very high. This is absorption property we pass in a similar way with the help of doping of the GD. This thing is happening there, and we are making this. This thing is happening. I'm just keeping all this thing. I'm just going to the final slide of MEAS. These are type of things which we have already measured. And how value changing we have measured also. Finally, I just want to show you this thing. Finally, the help of apart worldwide or GD worldwide, we have successfully developed a device like this, where in place 1 drop of water, we can easily find out the places from the places format. We can easily find out whether that material contains chromium or not, and if the chromium is there, then the absorbance will change, and depending on the percentage of the chromium present in that water, we can find out the change in the fluorescence property. And not only the fluorescence property, we have measured this fluorescence property with the help of electrical current. So current will change depending on this. And this device is very helpful. If you can use this device in anywhere, you can bring the copper material to remove that from the water. So these are the thing which we have done in a short, and this is the thing what I told you. If you give 1 drop of water, then the absorbance will change, and depending on the absorbance, the current will change, and from that change in current, because it is not possible for us to carry a fluorescence spectrophotometer anywhere. So that is why we make a collaborative calibration curve between fluorescence property and the electrical property. So that depending on the fluorescence property, the current will change, and looking into the current of the material, we can easily find out the chromium content of the material, and we can find out that the material is contained in chromium or not, and from there we can remove the chromium. These are the things that we have. I just want to tell you, this is the conclusion. Basically, being a physicist, I don't have any model, but with the help of model, we finally reached to the goal where we have developed some material, and which material should be doped there or which material should not be doped there, but depending on their atomic structure or density of the charged particle in that material. We measure that first, then we go for the experiment, and we successfully do that one. Thank you very much.
Thank you so much, Prof. And for me, that was a very, very powerful presentation. And I don't know how of us listen to that presentation. And sometimes when you see somebody move from an area that is not just forced to mathematics, now he started looking at detecting chromium in water, and then having to relate that to the electric property of that of the water that is collected, and then he brought it into modeling and we'll see how mathematical modeling now helps us, to be able to measure that relationship in order to talk about if chromium is actively present or not. And then started talking about the issue of doping and all of that. That's very beautiful for me. And then the maths that came out of it. And like we normally say, it's not for us as applied mathematician, it's not in the it's not necessarily in the rigor of the analysis, but in the critical thinking, that brings us to application. And that's what he has demonstrated, moving from real life, having to deal with issue of water, detecting a problem in water, into mathematics, and then back into that. So please can we appreciate him for that very beautiful presentation. Now I'm going to allow us to ask questions. Now I have people here who are of chemistry background, of physics background, of math background as well, who are seated. In case maybe there are questions, please you may signify. Yes, I already have a hand up there. So I'll give 1, 2, 3. That's a beautiful one. Any other? Okay, 4. Okay, that's good. Any online participants, please, you can check them in case they have questions. So according to your number, please, let's move forward so that I will not have to be going back and forth because of the mic. We have just so much, and I don't want people to express themselves. So you just take the mic and then you ask a question. Thank you.
So the first question I want to ask the doctor is the design process without saying so. I want to summarize the design process with extension. We about the design with single to explain what I wanted to repeat in some design. And we want to work like do people, there is an element about the very bad foreign element we management and foreign and like maybe to maybe also detect and charge people or something. I want to ask that how is it practically again? Because it does I don't see, for example, you have a element, they just introduce it like let's say the element is a new type liquid form. You bring in that foreign element also in the liquid form just because it is how is it done practically? The last one I want to ask you is this particular slide, when you get it and the papers, like, is it, are they available on
Thank you. Actually, I told you earlier,
It's moving. You check. Oh, it's follows It's this body, it depends on where you go. Let's be paying attention to the presenter too. So when they if you can pay like one on my platform, just pass. Any question? Okay. So solve that.
Тогда починаю биться сидит, а в тень писать, ты же можешь лечь, что ты думал.
if we look into the graph, you can easily find out these two are blue and copper. Then copper are there, and this is nickel, then nickel is there. But here, one copper is there and one nickel is there. So if copper and nickel are side by side, and here the copper and copper are side by side, so the density will be different on the point of view of the charge particle. So when these densities are clearly the density function of this thing will be completely different than this thing. Now the question is whether the structure is like this or like this. I am predicting that the structure should be like this, but actually the structure is like this. Now the question is how we can verify that. That is why initially we verified that with the help of ritual pressure measurement. What we have done there, we make a crystallographic structure there, and after that crystallographic structure, we define the all thing. That means the peak, peak white, wind, peak intensity, and all this thing. And from there, we find out a structure which is available in the database, available in the database. What should be the structure? Then we match this structure with that available structure. If these two matches, then only we can tell you that the structure is like this or like this, because we cannot see the atomic position exactly inside the material, because atom cannot be seen. It is so small. We cannot see the position of the carbon or electron or all these things. We can measure that in the known structure. And so what we have done, we have measured, we have find out a structure from our material, as well as we have a previous structure. Then we match with these two things, two structure, and from there we can easily find out whether the structure is like this or like this or like this. What type of materials are there? If we find out the structure, then from there it is not difficult to find out the density of the material. And if you find out the density of the material, from there you can easily find out what should be the absorption of the various electromagnetic waves in that material.
Okay, thank you so much. I'm satisfied. Okay, can we get the slide? This slide,
Yes.
presentation slide, can we get it?
We
Okay,
slide,
it's finished already, so you will get it.
the slide is here.
Yeah, it's ready. Okay, so let's get. All right, yeah, I'm soon going to indicate to ask questions about it. All right, thank you, Professor. That's for the beautiful presentations. I find it quite interesting that you are using physics to solve real life problems in India. Thank you very much for what you are doing. My question is on the Avash device that you designed. I want to ask, it's also designed for household use or domestic use at household? All right, so after detecting the chromium in the water set household level, how do you remove the chromium from the water at household level now?
Actually, from our beginning one, which we have done with the ground acacia, this one is not very much difficult. Only difference is ground acacia is not available in many places, but copper and GD is available in throughout the world. As well as if we don't have this ground acacia here in Nigeria, it is difficult for us to develop that material. But copper or GD is available here, so we can develop that. And moreover, the intensity of the absorbance is more for the GD and copper. That is why we shifted from ground acacia to the GD and copper. And now the thing is, if we have that type of powder and if we use that in the water, that chromium will be absorbed in the surface. That will not give any fluorescence. And you just remove that copper powder from there, and then you heat it, then the chromium will go out of water from the powder, and you can use that also. You use that powder in the water, it will absorb, chromium will be absorbed on the surface of the material. You pick it out, the water will be free from the chromium, and this powder with a heat treatment, it will be difficult to heat treatment, but it is not very difficult. We have done all these things, we have not told here. If you can easily remove chromium from the powder and you can use that also. It is not difficult.
Well, thank you so much. I think the next question is similar, so is there anything to ask it again? Okay. Thank you very much. So my question is similar to what my colleague here just asked. So, but I also want to expand on that. So we're talking about the application now. So you talked finally that we can do that water transference. That is very important. So I also want to, because when you started, you pointed out some conditions, depends on the premium, more than like the new basket, the sea, and the rest of that beginning of this time. I want to have we sort of also on how in terms of how can this become there and also programs to get to draw to also pass some kind of condition. He's talking in drug development now. How can we draw a here on the other one now?
We can actually, we have seen that water is much useful for the, more useful for the cultivation part. If we use that in the cultivation field, then paddy will grow very well, very good condition. So that water is completely free from water. That I don't know whether that water is suitable for the drinking. I don't know. We have not done all that type of work, but we have seen that water is suitable for the cultivation purpose. And plants grow very much. We have published few paper also on that, and it is very useful water.
Okay, so the question.
And that water, from that water, there will be no chance of cancer or any white spot.
Okay. So the question is asking that if somebody has taken water that is contaminated with chlorin. Now, the same approach of removing chlorin from the water, and that can we also use that approach in drug development so that if somebody that perhaps has taken water that is contaminated with chlorin, such drug also has the capacity of removing it. So it's coming in terms of drug development now.
So actually, we have still thrown in a 0.0002.25 ppm water we can detect it. And it is near about 0.005 ppm we can withstand in our body. So it is not very harmful. And not only that, we have run this material in the cell line. In the cell line, we have run this material. We have seen that in the cell line, this percentage is not very harmful. Cell line is remaining the same, harmless.
Okay, thank you so much for that discussion. If you have to
You want to show that? No, if you have taken that, I have no objection. But I can give you that water which is removed from the heat from the.
Okay.
If you have taken already, then I have done. And I have connected these topics because I have seen Nigeria is affected due to this Chromia bleach water. From the South Asia, I have seen in Africa, many countries suffering.
Well, speaking from the life science background, so if anyone is interested in drug discovery, because we don't translate the experiment from the physical lab directly to humans, right? So if there is a lead from laboratory experiment concerning the efficacy of any treatment method, you have to first of all design an experiment in animal models. For example, you can use mice or rats. Okay, introduce that particular chemical agent into them. Look for the procedure that he has explained in order to treat it if it works, in animal model. Then if you have a fantastic result from there, then there are steps to take, because in the medical sciences, you don't just use humans as the key for experiment. So there are series of steps. Yes, you can go into maybe clinical trials and so on. So anyone that is interested as query goes to the life sciences, they can use, that's a very good project that you can begin to use into, because you can use animal model to first of all see what is going to happen in terms of toxicity as well as in terms of treatment or are trying to ameliorate one consistent.
Thank you
Yes,
so much.
it is really a long travel from the laboratory to regular life. We have done we have just started the work. Now, if I want to bring this to the society, then there is a long distance we have to travel.
Thank you so much.
Thank you, everybody. And so, sir, I just.
Any more questions?
Thank you. Thank you, no problem. I have no problem. Huh?
Sure.
No, no.
First question I want to ask, as touching designing a drug in removing a premium from human loss, I think what aspects which I will try to say, I'm here on conclusion. Yes, sir. The is, as you said, issue of premium, or the economic that is very common, length. Can we also use this model? It's meant to also design what can be used to detect length. Just also length tension.
Yes, this is the layered casting, all are different people work. We have no question that but this type of thing may solve because the density function, if you make a super cell like this, and what type of material can be absorbed, can absorb the layer and that type of thing. If you can do that, I think this is not impossible. The procedure is similar. But we have to make a model, mathematical model, and then other mathematical models will be applied in the regular the laboratory scale. And from there, it is not. I don't think it is difficult because in case of chromium, in case for the chromium, we are using copper and GD. Similarly, for lead, we may get another type of material which may be dope there, and from that material, another type of density function will be there, charge density function will be there, and it is not impossible because all material, any atom is nothing but some charge, and that charge can be used as a weight. So that weight, where it resonance, where it superposition, where it reduced to zero, it is just matter of thing. After a long experiment, you can easily find out, and accordingly, you can do that experiment. I think you will get you believe. I confirm.
So this talking about premium sport, premium stick.
Oh, yes, we have done all these things for chromium 6 because chromium 6 is much harmful than a chromium 4. We have done this for chromium 6. Similar thing, we have tried work with chromium 4. We have partially successful, but not 100% successful. That 0.0005% is not removing there. We have done with chromium 4, but chromium 4 is much less harmful than the chromium 6.
Okay, so now I'm sure that our and then get some rest. Then you imagine that he has been starting all the while. Please let's do it in this. We are looking at because children are really a very important also. So what we are going to do now is that we allow the remaining people who ask questions. So please interact with it correctly, and they will be available for such interaction.
At last, I just want to convey one thing to the convener, that everybody is making model for the experiment, and please forgive me, I have not done that type of thing, but I have used the model to get the result. That is different. Thank you very much.
You have to ask All right, thank you so much. Because of the information that we have. Okay, now, you want to agree with me that what has done the very they have done very well. And when we talk about appreciation to you, so I would hand over to Mike now to Mr. Emmanuel and allow you to carry to do the appreciation and presentation of pledge. So, thank you.
Very much. There's a pass. Without really anything. I give me out about those. So we need to thank you today. More for no. Speak up. Excellent work on behalf of the National and the Foundation. Thank you very much for the projects.
All right, thank you so much. And you know that when you get the sound of buying, you have to just be yeah, so all right, thank you. Okay, now we're going for we are going to start session. We have for those of us so yeah. It's
not with us here.
Okay. Yeah.
So, is with